Hello and welcome everyone to the third module of this batch. This is going to be the last module. How is everyone doing? Hi Rajesh. Hi Eva. Hi Nitin. Good. I'm good, guys. Thank you. So, guys, let's just wait for 2 3 minutes before starting. Hi Shweta. So, guys, while we are waiting for others to join, if you have any question from yesterday's session or anything we have discussed in past two sessions, we can talk about it. No questions? So, guys, we talked about MapReduce yesterday. So, basically, we talked about how exactly, basics of MapReduce, how exactly MapReduce works, right? So, today we'll dig deeper into the concept. So, if you don't have any question, let me ask you some questions that we discussed yesterday. So, can someone tell me, like, what is the input to a mapper in a MapReduce job? In what form is the data presented to a map function? All right, Eva, that's correct. In the form of key and value. Yep, that's correct, Jayesh. So the data is presented to a mapper in the form of keys and values. And what is the output of a mapper? Okay, Eva is saying output is key and a list of values. No, that's actually input to the reducer. So output of a mapper is a list of keys and values. Okay, so if you remember the word count example that we discussed yesterday theoretically, so in that, in a particular line, you might have, let's say, 10 words, right? So the output of the mapper is going to be, list of keys and values. and every key value is a word and a count of 1, right? So if a line contains 10 words, then the output of map function is going to be every word as key and 1 as value, and there will be 10 such key value pairs, right? So output of a mapper is a list of keys and values. However, when the data reaches the reducer, at that point the framework will combine all the values corresponding to a key, right, and put them together into a list. So the input to the reducer is going to be one key and a list of values. Corresponding to every key, there will be a list of values. Right. Anyways, so today it will be more clear when we talk about a practical example. So as I said yesterday, today mostly it will be hands-on. We'll be walking through some of the code portion of MapReduce job, right? And I'll be explaining some more concepts, how exactly framework consumes the output of mapper, how exactly it makes the input for the reducer, right, that we are talking about. So today we'll dig deeper into those concepts. So I think it's time to start. Most of the people have joined, so let's go ahead. So guys, this is the last module of this batch, which is about MapReduce. And objectives for today are to understand what exactly is MapReduce. However, we have already discussed what exactly is MapReduce, so that part is already covered. So today we'll be talking about what is shuffling. Shuffling, as I mentioned yesterday, shuffling is basically the part between map and reduce. So once your map function has given its output, right, then framework does the shuffling, and during the shuffling it creates the input for the reducer, right? And during shuffling itself, basically there is a concept of combiner and there is a concept of partitioner that we'll discuss today, and then finally we'll just work on the demo. So I hope uh, the session is interactive today, because that is the only way you guys can understand all the concepts, right? So we'll spend some time on the demo today. And finally, in the end, we'll talk about some of the advanced concepts of MapReduce. We'll not dig deeper into those advanced concepts today, because that's part of, like, that needs a complete session itself, and that's part of full course. So, but we'll talk a little bit about the advanced concepts. All right. So, what exactly is shuffling? So, before moving on to shuffling, let me open the notes from yesterday's session. So, yesterday we talked about an example where our input was in the form of you know denomination of coins, right? So we had numbers in a file, and every number meant denomination of a coin, right? And finally we wanted to find out frequency of each number. In other words, we wanted to count of each denomination of the coin, right? And we said that our map function is going to output, it is going to take input in the form of key and value. Key is going to be the offset within the file, value is going to be the record itself, and in this case the record is the line or the denomination of the coin. And output of map function was going to be the denomination as key and count of 1 as value, right? So let me actually now move to word count example here, that will be more explanatory for this concept. So let's just say, in fact, instead of word count, let me think of some other example, more easy to understand example. So let's say our input data is in the form of employee ID, right, department, and let's say uh, expenses. Okay, so it's like corresponding to every employee ID, there is information about to which department that employee belongs and how much money he has spent, right? So let's say employee ID 1 belonging to sales spent $100 employee ID 2 belonging to engineering, spent $200. Employee ID 4 belonging to IT, spent $250. So we have data in this form, right? So there could be multiple employees belonging to the same department. So I'm just building some input data so that the concept is clear, right? Right. So let's say this is our input data, right? So this is going to be almost like a real life example, right? So in real life, let's say you have such a data set where you have employee ID and the department to which the employee belongs and the money that he has spent, right? And our problem statement is find out total expenses for each department, right? So now guys, if you are familiar with SQL, can someone tell me that if I had this data in the form of a table in MySQL or any relational database management system, what would be my SQL query to find out the total expenses for each department? Just imagine that this is a database table, right? And these are the column names of that table. Can someone tell me what could be the SQL query to find out total expenses for each department? Okay, Rajesh is saying select department and then sum of expenses from table group by department. Correct. That's absolutely right. So it is like select department and sum of expenses from whatever is the table name and group by department. Right? So this is a very simple SQL query. Now, obviously, if your data set is small, you're good with SQL and you don't need any framework like Hadoop to solve such a problem, right? But now think of a data set which is in the range of terabytes. Normal relational database is going to take hours to give results for such a query, right? So that is why we need a framework like Hadoop to solve such a problem. Now, let's try to figure out how to get the same result using MapReduce, right? So this is the SQL way of getting the same result. Now let's talk about how to get it using MapReduce. Now, based on whatever we discussed yesterday, can someone tell me what would be? So this is going to be input to my mapper, right? So key, as I said, is going to be offset within the file, and value is going to be each record at a time, right? So can someone tell me, let's say if my map function is something like this, right, where value is one record at a time, right? So can someone tell me what would be my key and value of mapper output? Okay, if I is saying key as department, so let me just say department is equal to value dot split on comma, or in other words, and department is equal to fields 1. All right, and expenses is equal to fields 2. All right, Rajesh is saying department as key and expenses as value. And Kumar is saying value and count is 1. So Kumar, we are not going to count the occurrences of each department. So if we were trying to find the number of employees in each department, then you would have been right. Then it would have been like key as the department and value as 1, right? Because 1 means 1 employee per record, right? But here we are trying to find out total expenses. So Rajesh, you are right. Our key is going to be the department and value is going to be the expenses, right? So here I'm going to write department as key and expenses as value, right? So what is going to be the mapper output? It's going to be sales 100, engineering 200, and so on, right? From every record we are just printing key as department and value as expenses. Now can someone tell me what would be the input to reducer? So let me actually copy this whole thing here. So this is the output of mapper, right? Now what is going to be the input to the reducer? Okay, Rajesh is saying sales and then list of 100, 600, 800 and so on. That's absolutely right. So basically as we discussed yesterday, input to the reducer is going to be for every key, there will be list of all the values associated with that key. So sales 100, 600 and 1500 and 800 also, right? This is going to be one record for your reducer. Another record would be engineering 200 and 1100, and then IT 250 and 900, right? So these three records are going to be input to the reducer, and your reducer logic is very simple. Corresponding to every key, just sum up all the values in that list. So finally you get the result as total expenses for each department, right? Yep, that's correct, Eva. So this is going to be the input to the reducer, and you are going to get output of reducer is going to be right. So this is what we wanted. So now this is exactly similar to the problem that we discussed yesterday of word count, right? Now let's talk about how exactly we have achieved this, how exactly framework has helped us achieve this, right? What exactly happened between the map and reduce? So this part is pretty simple, that your mapper function receives one record at a time from the framework, right? Your framework will know where input data is present. It will read one record at a time and pass that one record at a time to the mapper, right? That's very simple. Now how exactly framework consumes the output of mapper and builds the input of reducer, that is something that we are going to discuss right now. So that is called shuffling, right? So shuffling is between the output of mapper and input of reducer, right? So now let me just uh, assume that our input data is actually distributed on the in the cluster, right? So we discussed yesterday that your input data would be present on multiple machines in the form of multiple blocks, right? So now what I'm going to do is I'm just going to assume that first three records are present on, let's say, one machine, next three records are present on another machine, and last two records are present on some other machine. All right, so we have three blocks of data present on different machines, right? In other words, there will be three map tasks running in parallel, processing their own chunks of data. So that means when I say map output, we need to talk about map 1. So map 1 is going to give this output, and then map 2. Map 2 is going to give this output, which might be on some other machine, right? And then map 3 is going to give this output, right? So these are independent tasks. They don't care about what other mappers are doing. This map task, it just got one record at a time, and it got total three records, and it just produced its own output. Similarly, this map task produced its own output without worrying about what other map tasks are doing, and so on, right? All the map tasks did their job independently without worrying about what other map tasks are doing. So all this is being done in parallel. But because one record of sale is being emitted by map 1, two records of sales department are emitted by map 2, one record of sales department has been emitted by map 3, framework needs to do something to bring all of them together, right? Because ultimately there is one record to the reducer which contains all the values of sales. Now, how does framework figure out which records or which output records from mappers need to be combined together, right? Now, let's just assume that we were running two reducers. Okay, we were running two reducers. Reduce 1 is one task, and reduce 2 is another task, right? In fact, let's just don't not worry about how many reducers are running right now. Let me first explain how exactly this all would happen if all the map tasks were running on one machine. So still there are three blocks and three map tasks are running, but let's say all of them are running on one machine, right? So how does framework combine all the records with the same key? So what framework does is, as part of shuffling, the first step in shuffling is sorting. Okay, and how does sorting happen? It will simply sort everything based on the key. Okay, alphabetically. So engineering comes first. So what it'll do is it'll say engineering 200, then comes IT, it says IT 250, and then comes sales, right? So first step is sorting. Why do we need sorting? The only reason behind sorting is because we want all the keys to be together, all the same keys to be together. So now if you look at this, all the records with the same key are going to lie together, right? Once you have sorted it, once the framework has sorted the data, it's very easy to club all the records with the same key together, right? Once you have this with you, it's very easy to arrive at this, right? Because you will always say, okay, first record is engineering, value is 200. Next record, if the key is same, I'll just put the value together. and I'll just keep putting all the values together unless I encounter a new key. And when I encounter a new key, I'll make a new record. I'll start a new record for the reducer. Does that make sense, guys? Why do we need sorting between map and reduce? Why does framework sort all the output of mappers? Right? So by sorting, it becomes easier to combine all the values of a key together. Right? But as I said earlier, there are three different blocks and they are not even communicating with each other. Right? At this stage, they are not even communicating with each other. So what happens at this stage is sorting is being done separately. So here I have shown that this is the final sorted output. But this cannot be the case when your mappers are working independently. Right? So let me write sorting output of every mapper here itself. So the first step to arrive at this is, so guys, if you look at it clearly, what I'm trying to do here is, this is the final result that I want and I'm trying to move backwards, right? To reach at this, first I need to reach at this, right? And how do I reach at this? First I will be sorting output of each map task separately, right? So sorted output of map 1 is going to be engineering, and I'll say just one value, which is 200. IT, and just one value, which is 250. Sales, and just one value, which is 100. So in other words, at this stage I am trying to create input to the reducer, although this is not the complete input, right? For every key, whatever are the values present within this output, I am just combining them together. I'm not worried about what is going to come from other mappers. Similarly, at this mapper, I'll say IT and value of just 900, sales and value of 600 and 800, right? Similarly here, I'll say engineering and value of 1100, sales and value of 1500, right? So we have partially sorted output of every mapper separately present at that place itself, wherever that mapper was running. This could be on the same machine or this could be on different machines. So for a better explanation of concept, let's just assume all these map tasks are now running on different machines. So on one machine I have this output present, right? On other machine I have this output present, and on one more machine I have this output present, right? Now what happens is, all of this data is sent to the machine where your reducer is running. Okay, all these three chunks of output of mappers is sent to one machine where your reduce function is running, where your reduce task has been scheduled or launched by the applications master, right? We yesterday talked about applications master. Application master scheduled these three map tasks on some nodes, right? And it also has launched one reduce task at some place. Okay, so now on some other machine there is a reducer running, right? And reducer receives all these chunks as input. In other words, it's not the reduce function, it's the reducer machine, right? And then this also, and then this also. So all this data gets together on one machine, right? In this form, because it was partially sorted and combined, right? This came from node 1, this came from node 2, right? This came from node 2, and this came from node 3. Now at this stage, once again sorting happens, because now you are kind of merging all different sorted outputs together once again sorting, and I would say grouping, right? So now if you again sort and group, now you will find that there are two records of engineering, and basically once you again sort and group, you will get this, right? Does that make sense, guys? So let me just explain the workflow once again. Your map tasks are running independently on different nodes, right? Each map task is producing its output in the form of key and value, key and value, key and value, right? Each output of mapper is sorted and grouped. So in on this node there was no grouping that happened because there was only one record corresponding to every key. On the second node, some grouping happened because there were two records corresponding to sales. On third node, there was no grouping that happened, right? But finally, when all this sorted output of every node or every map task was sent to one common place where your reducer was running, right? Again, you sort and group this output, and finally you get the input ready for the reducer. Eva is saying, okay, so sorting and shuffling is the same. Yeah, Eva, so sorting is part of the shuffling process. So there are basically three major things that happen, you know, as part of shuffling. Sorting is one of them. So I'll talk about partitioning also, but for now, let's not worry about partitioning. Okay, partitioning is required when there are multiple reducers running. Okay, I'll talk about that in a while, but for now let's just assume there is only one reducer running, and all this output from multiple map tasks is has to be sent on one machine where your reduce function is running, right? Okay, Mahavir is saying sorting happens in both map and reduce phase. Yeah, Mahavir, that's correct. So sorting happens on the output of every map task, right? As I said here, every map task's output is sorted, right, separately. And after that, once all this sorted data reaches the reducer machine, it again needs to be sorted and merged, right? Because now your your records corresponding to the same key could be coming from multiple map tasks, and they need to be grouped together. And for that, you again need to sort them. In fact, if you guys know about merge sorting, the sorting that's happening on the reducer side is actually just the merge part of the sorting, because it already gets you know partially sorted chunks of data. All it needs to do is merge them together in a sorted way. Is that clear, guys? Do you understand why the framework sorts the output of mappers and how it exactly sorts the output of mappers? Guys, this is one of the most important parts of MapReduce. If you don't understand this, just let me know. Okay, Eva is saying one more time. Sure, Eva. Let me just go through this once again. So, so this is my input, right, for the complete job. And what I am assuming here is the input is present on three different machines, and these are three different blocks, right? So that means there will be three different map tasks running, which and they'll be getting input records from these three blocks. First map task will get the first three records, and it will give its output as department as key and expenses as values, right? So this is going to be the output from map 1, right? Similarly, this is going to be the output from map 2, and this is going to be the output from map 3, right? Now all of this output somehow has to be combined, right, and sent to the reducer in this form, because only then your reducer can sum all the values corresponding to a department, right? So now how do I reach from here, right, from here to this input to the reducer? How do I make this out of the output of mappers? Now way to do that is, every mapper's output is first sorted and grouped. So when I sorted this, I got engineering at the first place, and there was only one record corresponding to engineering. So I just put the value of engineering in that list. I am still considering this as a list, right? But it just contains one value. Similarly, IT also contains one value. Sales also contains one value. In case of mapper 2, sales would contain two values, right? Because there are two records corresponding to sales. IT would contain one value, right? In case of mapper 3, engineering would contain one value and sales would contain one value, right? So this is happening independently on different nodes. Output of every mapper is being sorted and grouped, right? But still to reach at this stage, I need to combine all the records of sales together. And how do I do that? What framework does here is, it will send all these sorted outputs from all the mappers, right? It will send these outputs to a common place where your reducer is running, right? At that machine, it got output from all the map tasks, right? And it will again sort this output and merge the values together. So if you look at here, corresponding to engineering, there are two records, this one and this one, right? So corresponding to engineering, you'll get two values in the list. Similarly, corresponding to sales, you got two records. One record has one value, another record has two values, right? And in fact, three records. Third record has one value. So all these values will get together into one list, right? Once you sort it, all the records of sales will come together, and then you can group all the values into one list. Similarly, for IT, you group two values into one list. So this is the input to your reducer. Okay, Kumar is saying sorting and shuffling are same. So Kumar, as I said, sorting is one part of shuffling. Okay, shuffling actually means you are shuffling data from mappers to the reducers, right? And there are a lot of things that happen in between. Sorting is one of them. We'll talk about partitioning also. That is also part of shuffling. Okay, Kumar is saying it actually do sorting and merging. Yeah, that's correct, Kumar. So we are sorting and merging. All right, guys. So I hope the sorting part should be clear, right? Why framework does sorting and how sorting helps in grouping the data together, and at what stages sorting happens. So sorting happens at the output of mappers individually, and finally when the output of mappers reaches the reducer, at that place also sorting happens again. Yep. So so after sorting, so guys, just don't worry about the slides today. So I won't be spending much time on the slides. In fact, there are not many slides there. So we'll be just talking about concepts, and then we'll be looking at the code in a while, right? So let me now talk about partitioning. What exactly is partitioning? Right, so we understand sorting now. Just imagine that instead of one reducer, so in this example we assumed that there is only one reducer, and all the output from all the mappers had to be sent to the same reducer, right? So there was no, decision making happening. You just blindly send all the output to the machine where your reduce function is running, right? There was no decision to be made, right, on deciding like which machine you have to send which key value pairs, right? So it was very simple. But when you have very huge amounts of data, one reducer could become bottleneck, right? In such cases, you would want to run more reducers so that you can even reduce the data in parallel, right? You might want to reduce the data in parallel. So now let's assume in the same example, let's assume there are two reducers running. Okay, so this was the output of mappers that was sent to the same reducer. But now let me just try to write it at the end. Let's say I have reduced 1 and reduced 2, right? These two are running. Now how does framework decide which mapper output should go to which reducer, right? So for example, if I blindly send some of the mapper outputs to reducer 1 and some other mappers output to reducer 2, then I'm not going to get the desired results. So for example, if I send map 1 output here, right, and map 2 output to reduce 2 and map 3 output also to one of these, let's say here. So do you see any problem with this, guys? Do you see any problem with this? Okay, Eva is saying, is it safe to say shuffling takes place at both map and reduce as well? So Eva, I would say shuffling takes place between map and reduce. It basically is a process which kind of takes your mapper output, right, to the reducer input. Okay, Rajesh is saying sales is not sorted in reduce 2. So Rajesh, once the data reaches here, again the sorting and merging would happen separately for this and separately for this, right? So sales, so eventually, basically you will have 1500 also getting here, right, instead of here. But I just copied and pasted the mapper output here. So these are the records that reach to the reducer machine from mapper outputs. What is the problem with this? Yep, Eva, that's correct. Sorting takes place at both the places. So guys, do you see any problem with this? If I'm running two reducers and I'm blindly sending some mapper outputs to some one reducer and some other mapper outputs to other reducer. Mahavir is saying output will not be correct because reducers will not talk to each other. That's absolutely correct, Mahavir. You're absolutely right. So these two reducers, they could be running on different machines, right? And they are not going to communicate to each other. They are just going to work in parallel, right? So output from this reducer is going to be, the output is going to be this itself, right? For engineering, it will say total expenses are 200. For IT, it will say 250, and for sales, it will say 100. And similarly, this reducer also will give output corresponding to every department, right? But how do you combine these two outputs now? You just got these two outputs separately, right? But the target was to have total expenses corresponding to each department, which is not happening because some records of engineering, reach reducer 1, some other records of engineering have reached reducer 2, right? But we need to make sure that if the key is same, the records should reach the same reducer, right? Only then you will get the total expenses for that particular department. Does that make sense, guys? Somehow the framework needs to make sure that output of mappers with the same key should reach the same reducer, even if it is coming from multiple mappers at different locations. The same key should reach the same reducer, right? So let me just write it here. Blind way of moving data from mappers output to reducer nodes, right? So this is a blind way of moving data. Problem with this is records with same key could land at different reducer nodes and they can't be combined or grouped together, right? Right way. So right way is using a partitioner. Now what is a partitioner? So partitioner is basically a simple function. Just think of a simple function which returns an integer, right? And it takes as input key, value, and number of reducers. Okay, so framework has a default function. Okay, framework has a default function which takes as input these three things: key, value, and number of reducers. And what is this key and value? This is going to be the output of every mapper. So whenever a map function emits its output, right? A map function emits its output in the form of key and value, right? So for every input record, it will emit a list of keys and values. In this case, it's just one key and value for every input record, right? On every output record of mapper, on every output record of mapper, so for example, this is one output record of mapper, framework will run a function called partition, right? So output key and output value of mapper will be passed to this function, and how many reducers are running for the job, that will also be passed here. Okay, so what this function does is it returns hash of key modulus number of reducers, right? Hash of key means it will calculate a hash on the key and it will divide it by the number of reducers and it will return the remainder, which means if number of reducers are 2, it will always return either 0 or 1, right? If number of reducers are 2, it will return either 0 or 1. If number of reducers are 10, it will return a number between 0 and 9, right? So it will always return a number between the range of how many reducers are running, right? If 10 reducers are running, it can return 10 different numbers in the range of 0 to n minus 1, where n is the number of reducers, right? So what happens is, if it returns 0, so in other words, you can say that every reducer, let me just call it reduce 0 and reduce 1, right? So if it returns 0, the output of that particular mapper or that particular record will be sent to reduce 0. If it returns 1, the output will be sent to reducer 1, right? So in other words, let's come back here. In other words, when you apply that hash function or that partition function on this record, which is on output of mapper 1 and on record sales 100, it will return either 0 or 1, right, depending on what is the hash value of sales. So I'm just assuming here, let's just assume that hash of sales is equal to 234. It's just an assumption, right? It could be anything, but whatever it is, if hash of sales is equal to 234, then return value of partition will be 234 modulus 2, right? Which is equal to 0. Is that right, guys? So if hash of sales is 234, or it could be any random number, but whatever it is, it will just mod it with 2 because 2 reducers are running and it will return the result. So at this stage, framework knows that I need to send this record to reducer 0, right? Now independently on some other node, once you get this record, you will again apply the same thing, right? Because hash is the same function. If you apply hash on some other machine also, you will get the same value, right? So you will get again reduce 0. So that means from here also, and from here also, and from here also, and from here also, this record will reach reducer 0. Does that make sense, guys? And if engineering returns reduce 1, from every node, it will get the value of partition as 1. So by using this partition function, your framework is making sure that records with the same key will reach the same reducer. Okay, Mahavir is saying, if in worst case for all records the output of partitioner is 0, then all records will go to single reducer. That's absolutely correct, Mahavir. That's absolutely correct. If by chance all the hash functions return such a value that you get the same partition ID, all the records, all the output of mappers will reach the same reducer. That's absolutely correct. But law of average always comes into picture when you are working on big data. And I have worked on, many number of big data projects, and all the time what I've seen is it always averages out. If I'm running 10 reducers, 99% of the times all 10 of them will get almost equal data. Okay, Mahavir is saying, then how to overcome, because here will not have any parallelism. So Mahavir, that's actually one of the advanced concepts. Okay, but let me just tell you one thing. So this partition function that I've just written here, this is kind of the default implementation that framework provides. Okay, but you always have an option to override this. You always have an option to override this. So let me just give you one very simple example here. So for example, if I know that I have roughly a million records of engineering and 2 million records of sales, so I'm just putting some assumptions here. Number of engineering employees are, let's say, I know 1000. Let's just assume some numbers. Number of sales employees are, let's say, 5000, right? Number of uh, IT employees are, let's say, 2000. All right. Now my default partitioner, there is always a chance that it could send all the records to one reducer, but I can write my own partition function. Let's say I have written my partitioner, okay, which will get key, value, and number of reducers and input, right? And what I can do here is I can say if key dot equals sales, right, return 0, else return 1. So I'm not even looking at any hash function. What I'm doing is all the records with sales department go to first reducer and all other records go to second reducer, right? So in that way, my one reducer will get 5,000 records and second reducer will get 3,000 records, right? So you can distribute the data according to your knowledge of the data. I hope that makes sense, Mahavir. Thank you. So guys, is the concept of partitioner clear here? Cool. This is the first time I've got yes from so many people. Very nice. So guys, we have discussed what is a partitioner, what is how does sorting happens. Now let me explain one more concept. One more concept is combiner. Okay. So now we just talked about how does reducer work, right? Reducer will get such a record as input and it will just sum all the values together. Now this is very small data, obviously, the example that we have taken. But now think of a case where you have millions of records, right? When you have millions of records, this list is going to be huge corresponding to a department, right? And if you are going to iterate on this list and sum all the values in the reducer part, it might take a long time, right? If this list is huge, it might take a long time. And further, one more problem is if you're sending, if you're sending, for example, from map 2, I'm sending this, right, to the reducer. Now, even at this stage, this list could be pretty big, right? So this was a small example, but effectively, let me just write combiner here. So we are discussing about combiner. So this list could be on every mapper, it could have many numbers, right? So I'm just taking any example here. So many numbers. So if you're sending all this data from the mapper node to the reducer node, this might be big data and there might be a lot of network traffic, right? But if you know that on the reducer side you are anyway going to sum all these values together, right? If you know that on the reducer side ultimately you are going to sum all these values together, you can very well do that on the mapper side itself. So aggregate, or I would say partially aggregate on the mapper side itself. So instead of sending this on the reducer node, or let me just stick to this example here, instead of sending this to the reducer, what I can do is I can send sales and 1400 to the reducer. Do you think that will help? So if instead of sending this, right, output is going to be same because eventually they were anyway going to get aggregated. Make sense, guys? So this is the job, this is the part done by a combiner. So a combiner is basically nothing but a mini reducer working on the mapper side itself. right? So you have kind of reduced whatever values you had got on the mapper node itself, and instead of sending all the values separately, you have just sent the aggregation of those values, or you have already applied the reduce function first, right? You got this, and then you sent this to the reducer node, so that if from some other node you had got, so for example here, so here we were saying that this is what you will get on the reducer side, right? So this is reducer without combiner, input without combiner, right? But if I had combiner running with combiner, then I would have got 1400 here, right? Because a mini reduce would have already aggregated this output on map side itself, right? So I would have got this on the reducer node, and eventually the final result would have still been the same, right? So a combiner basically helps in two things. One is less traffic from mapper to reducer, right? Second is less load on the reducer. Does that make sense, guys? You can partially aggregate on the mapper side itself using a combiner. All right, let me just look at the questions. So Mahavir is saying, is MapReduce runs for reading and writing a file process from and to HDFS? That's correct, Mahavir. MapReduce reads its input from HDFS and it will write the output to HDFS. Okay, Eva is saying, so combiner before reducer after sorting and shuffling. So Eva, so basically if you look at this, there is output of mapper, right, which gets sorted first. So if you look at this, so this is output of mapper, right? This is the output of mapper. First it gets sorted, right? So let me actually write the flow here. So first is input to map, and then output of map, or in fact I should write from HDFS to map, right? From map sorting happens, grouping happens, then combiner works, right? So if you look at this, this is the output of map. First it was sorted and then it was grouped, right? Sorting and grouping happened and you got this. Then a combiner will run which will combine this, right? So after grouping, combiner happens, right? Then transfer to reducer, or in fact I would say partitioner, right? Partitioner will decide the partition ID, and then corresponding to the partition ID you will send those records to the reducer, right? On the reducer side, because you are getting multiple such transfers from multiple nodes, you will again sort, you will again group, right? And then you will finally run reduce function, and your output goes to HDFS. So your input came from HDFS, one record at a time it went to map tasks, right? Output of mapper is sorted, grouped, combiner runs on the output of mapper, right? Let me actually also write optional here. I'll explain why it is optional and where you cannot run a combiner. Okay, so it is optional. combiner runs, then partitioner decides the partition id, right? Corresponding to the partition id, you send the data on that particular node. On that particular node, again sorting happens, because multiple such chunks of data are coming from multiple nodes. You again sort and you again group, and finally you reduce the data. So if you see, combiner and reducer, they are kind of always running after the grouping, right? Combiner is running after the grouping on the map side, reducer is running after the grouping on the reduce side, and finally reducer output goes to hdfs. Okay, Kumar is saying, so what is the job of the reducer if this is done by combiner? So Kumar, as I just explained, so if you look at this, if you just look at this, even with combiner, you got multiple records of sales, right? One is here, one is here, and one is here. Combiner is just reducing partially, right, on one mapper output, but you would still be getting same key from other mappers also. So reducer will be basically aggregating all these things again, right? So you still need a reducer. I hope this flow is clear, guys. All right, so that was about the combiner, right? Okay, Kumar is saying, please help me understand how to choose key and value of mapper and reducer. So Kumar, you only choose the key and value of mapper. Okay, let me actually help you decide that. So we talked about an SQL query, right? So for this particular problem, we talked about what would be the SQL query to solve this particular problem statement, right? Let me just try to kind of map this SQL query to MapReduce. Okay, so whatever is in your select part, whatever fields are there in your select part, typically they are your mapper output keys. So in this case, department is the field that you are choosing, right? You are selecting in your select statement. So department should be your mapper output key. Okay, sum is a function. So let me just separate it a little bit so that I can map everything. So sum is a function that is your reducer logic. So remember, we what we are doing with the input to the reducer. So this is my input to the reducer, right? So, and what I'm doing with all these values, I am just summing them up, right? And that is what my function is in the SQL query. So reducer logic is this function, right? And whatever is the key on which you are applying this function, that key is typically mapper output value. Okay, so whatever is the field on which you are applying this function, that field is typically the value of your mapper output. So you have decided what is your output key of mapper and what is your output value of mapper, right? I hope this analogy should be clear. Okay, Aryan is saying, do we need to write codes for sorter, shuffler, combiner and partitioner as well, or for only mapper and reducer? So Aryan, by default, you don't need to write any sorting, shuffling, combining, partitioning. Okay, framework provides the default implementations, but there are cases where you might want to override them. So one of those cases we discussed, right, where you want to override the partitioner. So we wrote our own partitioner where I said if key is sales, then return 0. If for any other key, return 1. Right. So in here I am writing my own partitioner. There are ways to override the default implementations, but by default you only need to write map and reduce. Okay, Mahavir is saying why and where secondary sort is used. So Mahavir, that's one of the advanced concepts. I don't want to get into details of it again, right? But secondary sort is when your key consists of multiple fields, right? And you want to sort based on one portion of the key. Okay. So when your key consists of multiple fields, in this case, we are just using one field as a key, but secondary sort is required if your key consists of multiple fields. But that's like one of the advanced concepts and it'll take a lot of time, so I don't want to get into details of that right now. Thanks, Kumar. Aryan is saying, and what about shuffler and sorter? We are never required to write codes for them. So Aryan, sorting is something that you can again override. Okay, so that depends on the use cases. In some use cases you might want to override sorting as well. So that code will not be part of a reducer or mapper. I'll just show you some code that I already have some portion of code where I've overwritten all this, sorting, grouping, and all these things. So I'll not get into details of that, but I'll show you where exactly you write that code. Okay, I'll show you that. So guys, that's all about the theoretical concepts of MapReduce that I wanted to talk about, right? And now I want to, take you all to a hands-on session where we'll go through the code, we'll try to run an example, and we'll see if we can even make some modifications according to whatever you guys want, and we'll see how does that code run. All right. But before that, let's take a 10 minutes break. Everyone okay with the break? All right, so let's come back after 10 to 12 minutes, or uh, precisely 9:25 p.m. IST. All right, that's 12 minutes away. Is everyone back, guys? Okay, some of you are back. Let's just wait for 1 more minute. So how is it going, guys? Is there some value addition happening, or what do you think about the flow of the class? Thanks, Siva. Thanks, Mahavir. So is there anything that you guys want me to, change the way I am explaining, or anything that you want to, you know, you want me to do differently? All right. So looks like everything is good. Thanks, Rajesh. All right, guys. So just before we move on to the code walkthrough, let me just tell you one more thing. As I said, the combiner is optional here, right? So when I say optional, it is up to us when we are writing our MapReduce jobs whether we want the framework to run the combiner or not. Because combiner is something that's not always usable. So when I say not always usable, that means there are some problems where it's not possible to run a combiner, where running a combiner would not give the right results. So in this example that we just discussed, because we just wanted to sum up everything, we could have easily run combiner here. But now just think about it. If the problem statement was to find out the average expenses for each department, okay, when you want to calculate average, you cannot partially calculate average and then find the average of averages, right? You need all the numbers separately together to find the average, right? So you could not have calculated partial average of map 2 here, right, and then use that value as one of the values in the final list. That would not have been possible, right? So when your function is average, you cannot use a combiner. So in that case, you will tell the framework not to use a combiner, right? Framework will use combiner only if you ask the framework to use a combiner. So that is why a combiner is optional, right? And second thing is, even when you have asked the framework to use a combiner, it is not guaranteed that every record will pass through a combiner. It is not guaranteed. It is up to the framework whether it wants to run the combiner or not. Okay, whenever there is enough load on the mapper side as well, it might skip the combiner also. So combiner should be run only when you are sure that whether combiner runs or not, result is going to be same. So for example, in this case, whether you run the combiner or not, your final result is going to be same. Whether you aggregate it partially here or not, your final aggregation is going to be the same, right? So only in those cases you should ask the framework to run a combiner. Otherwise, don't ask the framework to run a combiner if you think that result could be different. Make sense, guys? All right. So let's look at one of the examples, code examples of MapReduce. So this is actually a word count example. Let me just remove these comments for now. So whenever you write a MapReduce job, there are three things that you need to write. One is the main function, one is the mapper class, one is the reducer class. So this is my map class, this is my reduce class, and this is my main function. So let's start with the main function. So in your main function, you need one object of configuration, which is by default. This is a statement which is by default there for every MapReduce program. You need to set the name of the job. This is something that is up to you. You can set any name here, right? And then you need to set the main class. Okay, set jar by class is the function used to set the main class. So the main class I have is word count class, right? And then you tell the framework which is my mapper class, which is my reducer class. We'll talk about the implementation of mapper and reducer class, but in the main function you just need to tell the framework. So this is the way you tell things to framework, right? When you say set mapper class, you are setting the class which will be used as a mapper class in this job. When you say set reducer class, you are telling the framework which reducer class you want to use. When you set the number of reduced tasks, right, this is the place where you set the number of reduced tasks to be run, right? And if you do this job.set combiner class, typically the combiner class is same as the reducer class, right? Right now it is commented out, but this can be commented, I mean this can be put in the code also, that you want to run a combiner. If this is commented out, then there won't be any combiner. If you uncomment it, then framework will try to run a combiner. Okay, then there are key and value types. So by default we use text as the key and int writable as the value. So these classes are provided by the Hadoop framework. There are options to override these classes as well, which is part of advanced concepts. So I'm not going to get into details of that. For now we'll just work with the text and int writable. So as we know from this example, that my key is going to be a text and my value is going to be a int, right? And for int, Hadoop framework provides a class called int writable. Okay, then you set the input format class. By default it is text input format, and output format is also text output format. In the advanced concepts we also talk about how to override these formats, right? So this is an option to even override the formats of input and output, right? And then you take two parameters, args0 and args1, right? And what I'm setting here is the input path and output path. Input path is where my input data is present, right, which I want to process in HDFS. Output path is the place where I want to generate the output. And then after that you just say job dot wait for completion, and it will run the job, right? And the core logic is in the map class and reduce class, right? So now if I go to map class, typically the map class will extend a framework class which is mapper class. It has four generic parameters. First two parameters are input key type and input value type. Next two parameters are output key type and output value type. So input key to the mapper, as I said, is offset within the file. So input is long writable. Input value is the record, one record line at a time. So input value is text. Output of mapper is key and value. So key is going to be text and value is going to be int, right? And within the map class, I have a map function. This is a function that will be run for every record in the input, right? And this function will take key and value as input. Your key is offset within the file, value is every record, and it also takes one object called context. Context is the object which we use to communicate with the framework here, right? So what I'm doing to begin with is I'm just saying whatever is my value, right, which is one record at a time, I'm just converting it to string and storing that in the line. Then I'm using a string tokenizer on that line. This tokenizer will by default tokenize the string on space, right? So basically target here is to count the frequency of every word in the file, right? Then what I'm doing is for every token in that line, which means for every word in that line, right, I am saying put that word into value. Okay, so I could have used another variable also here, but I'm just reusing this value variable. Okay, in fact, let me use another variable so that it's clear what exactly we are doing. So let me just say text output key. Okay, and then output key, right? So now this should be more readable here. Yep. So what I'm doing is my output key is that token, that word, right? That word is going to be my key and my value is going to be 1, right? For every word I'm saying my value is count of 1. That's the whole logic of my mapper function, right? So as we discussed the word count problem, for every word I'm just outputting a value of 1, right? Key value, right? So because it's a while loop, for every word in that line it will emit one key value pair, which means it's emitting a list of key and values, right? And for reducer again, we have the input key and value types and output key and value types, right? And my reduce function, what does it get as input? A key and a list of values, iterable, interiterable, right? So as we know, input to the reducer is a key and a list of values, right? So that's what we are taking as input here. A key as input and a list of values as input. And again, context is something that we'll use to communicate with the framework. For example, here in the map function, we use context to write the output, context.write, right? So in the reduce function now what I'm doing is I am initializing a variable sum with 0 and then I am iterating on all the values in that list, right? So for example, this list, I will iterate on all the values and I am just summing all the values in the sum variable. So once this loop is over, that means I have the sum of all these values in sum variable, and context.write is the output of reduce function, where what I'm doing is for that key I am writing the sum as value, key and value, right? Does that make sense, guys? Do you want me to run this program or do you want me to explain something that you have not understood from this? Okay, Eva is saying explain again. All right. So as I said, there are three things. One is the main function, one is mapper class, one is reducer class, right? In the main function, we are just setting some parameters for the framework. I'm just telling what is my job name, right? What is the jar name, main class name, what is the mapper class, what is the reducer class, right? How many reducers do I want to run? My output key and value types, right? This is the output of reducer. Output key of reducer, output value type of reducer, right? Input and output formats, by default these are text input and output formats. And then I am setting what is the input path where my input data is present, and what is the output path where I want to generate the output, and I am taking them as parameters to this main function, right? Through args 0 and args 1. So when I'll be running this job, I will be providing these parameters at runtime, where my input data is present and where I want to generate the output, right? So that's my main class. In my mapper function, right, this is my map function. In the map class, I am taking a key and value as input. I am just ignoring the key because I don't care about what offset is within the file. I just care about what record I have got to process. For that record, I convert that record into string first, from text to string, right? I tokenize that string into words. For every word in that tokenized string, I am emitting a key and value, and my key is that word and value is 1, right? Similarly, for in reduce function, I am taking key as input and list of values as input, right? So between map and reduce, as we have already discussed, framework will convert the output of mapper to the input of reducer, right? Corresponding to every key, it will provide a list of values, right? So I am just iterating on the list of values and summing up all the values, which means corresponding to that key, I have got the count of occurrences of that particular key in that file. You're welcome, Eva. So guys, let's just try to run this program. So let me just create a jar out of it. Right, so let's name it word count.jar. So now I'll just go to my virtual machine. I'll first copy this jar to this virtual machine because I have created this jar on my laptop, right? It's not in the virtual machine. Let me just look at the IP address 192.168.1.106. So I'll first copy this jar on this virtual machine. Right? So I have this word count.jar. And how do we run a Hadoop program? Let me just write that also in the notes. The command is Hadoop jar and then jar name, main class name, and then input path and then output path, right? If you remember, we were taking these two parameters in the main function, right? Input path and output path. So now let's just try to run this Hadoop jar word count.jar, and what is my main class? com.selfreflex.word count. This is the main class, and my input path. We need to first create an input path. So let me just abandon this command for now. So let's just create a dummy input. So let's just write anything. So let's say this is my input, right? So we are counting frequency of every word. So we expect Hadoop to be coming twice, SelfReflex to be coming twice, right? And so on. So whatever words are there, we'll just get the frequency of every word, right? So first thing we need to do is put this file into HDFS because Hadoop or MapReduce runs on HDFS, right? So first let's create a directory, Hadoop dfs minus mkdir, let's say slash data, and let's say slash data input. Hadoop dfs minus put is the command to put any local file into HDFS. Okay, so I'll just document these commands for you so that you guys get them with the notes. So I'm just putting input.txt into slash data slash input in HDFS, right? And Hadoop dfs minus ls is the command to list all the files in a particular directory in HDFS. So if I run this command, it will show me this input.txt being present in this particular directory, right? Now let's just run our MapReduce job. So this is the command we were writing: Hadoop jar, then jar name, then the main class name, and then the input path. And what is our input path? Slash data slash input. And let's say I want to generate my output in slash data slash output, right? When I run this, it will run a MapReduce job, and it also shows some statistics about the job. If you see how many input records were there, 3 input records, right? Because there were 3 lines in that file. How many output records were generated from mapper? 14 output records were generated from mapper, because for every line there were many words in that line, right? And for every word, map function generates 1 record as output, and then reduce input groups and reduce output records, right? So let's just first look at the output. Slash data slash output. If I just do a ls here, it will show me a part file here, right? So the output of MapReduce job is generated in the form of part files. So because we are running one reducer, it has generated one part file. If I was running more reducers, then I would have had multiple part files here, one part file for every reducer. Hadoop dfs minus cat is the command which displays the contents of a file on screen, right? So if I run this, it will show me frequency of every word, right? That's what we were expecting, right? Hadoop is coming twice, is coming twice, SelfReflex is coming twice, and so on. Does that make sense, guys? Now, do you want me to make any changes in this program? Do you want me to try something that you think will make things more clear? Just let me know. So this was a word count example, right? Do you guys want me to change this code to work on this example that we just discussed to find total expenses of each department? Should we try that? All right, cool. Everyone wants me to do that. All right. So now let's just go back to our code. So if you look at this code, guys, most of the times your main function is going to be like this only, because everything else is same, right? I'll just set the input path, output path, and I'll set the mapper class, reducer class. Only thing that I'm going to change is the logic within the map and reduce, right? Right now, in this case, my input is in the form of, where is my input? Yeah, this is my input, right? So my input is going to be in the form of such records where I have three fields: employee ID, department, and expenses. So in the map function, now I am expecting my value to contain that record, right? And now let's just split this string. So let me just use string, let's say fields, array of fields is equal to line dot split. Just a second, guys. My laptop is a little slow today. Lines dot split, and I want to split on comma. Right now I don't want to split on space, which was the case with the word count example. Now I want to split this line on comma because my fields are comma separated here. Right? I split the fields on comma, and now I know my department is on index 1, right? And let's say int expenses is equal to, is that correct, guys? So my fields 2 is the expenses, but because it is a string, I'm converting it into integer, right? So this is my department and this is my expenses, right? So let me just remove this part, and I don't need a while here because in every record I know there is going to be only one key and value, right? So I don't need to loop on the keys and values because I know in every record there is only one department and one value of expenses. So what I can do here is context dot write what is going to be my key, department. I'll say new text because my key type is text and not string, but department is a string, right? So I need to make a text out of it, and new int writable expenses. Does that make sense, guys? As small as that. Look at just this map function. It's as small as that. You just parse that one record, you get the department and expenses out of it, and you just write your key and value as output, right? Do you think I need to make any changes in my reduce function? Anyone? Do I need to make any changes in my reduce function? Yep, you guys are right. I don't need to make any changes in my reduce function because here also I just want to sum up all the values that come as input, right? Corresponding to every department, whatever values I get, I just want to sum all the values. So my reducer remains same. So now let's just make a jar out of it. So now let's name it total expenses.jar. Self, yep. All right. Let me copy this jar here again. All right. So I've got the jar. Now let's create a set of input for us. So let's say uh, emp.txt, and let's see if I can copy it from here to my virtual machine. I don't think I'll be able to do that. Let me just write all these entries here. 1 sales 100, 2, let me just call it engineering like this, 200, 4 IT, 250, 5 sales, 600, 7 sales, 800. Right. So let's say this is our input data, and again let's copy it. Let me first create another input directory for this. Let's say input 1, and let's just put this data in this particular directory. And run our jar. Total expenses.jar com dot self-reflex dot. Still my class name I did not change. The class name is still word count, so I'll use the same, right? I did not change the class name, but my jar is total expenses.jar, right? And my input path is slash data slash input 1, and let's generate the output in slash data slash output 1, right? All right, let's see what is the output. So in output 1 there should be a part file. If I do a cat on this part, I got total expenses corresponding to every department. That was easy, guys, right? So if you think about it, now for the demo purpose, we were using it on a very small data set, right? And on just one machine. But let's say I want to run this logic, or I want to run this jar on huge data set, let's say billions of records. I don't need to make any changes to my program. I don't need to write any code at all beyond this. I can run the same jar, I can take the same jar on a cluster of 100 machines, right? Where billions of records are present, or terabytes of data is present in this form, and the same jar will process the data using the power of 100 machines without any changes at all, right? So that is the power of Hadoop. Okay, Shweta is saying, could you go through detailed output? So Shweta, you mean the detailed output of this program that I just ran? You want me to go through the output? So output is just for every department you have got the total expenses, right? That is what we were expecting. Just a second. Okay, you want me to go to the code part? Let me just open the code. So in the map function, if you see, what I'm doing is I'm expecting my record in this variable which is called value, right? I am splitting this record based on the comma, and I'm picking the second field as department and third field as expenses. And then, as we discussed, my key is going to be department and my value is going to be expenses. That's all I have to do in my mapper. In my reducer, I know that I will get list of values as input corresponding to every key, and I'm just summing up all the values together and then writing the final output, which is key, which is going to be my department, and the sum of all the values corresponding to that key. Oh, okay. You want me to go through that stats when I ran the program? All right. Let me just go to that. Just a second. Just give me a second. Yep. So yep. Here. So this was for the last job, I think. Yep. It shows you a number of stats regarding like how many bytes it read from the SDFS, how many bytes did it write to the SDFS, how many read operations were performed, things like that, right? This is also from the last instance. So if we just talk about this particular instance, yep. So number of input records to the mapper were 8, right? Because we have 8 input records here. Map output records are also 8 because corresponding to every input record, I just emitted key and value from that record, which is one key value from every record, which means output records from map was also 8, right? And then this is the number of bytes that I emitted, right? Output materialized byte is like how many bytes were written, split bytes, and all these stats are related to some advanced concepts that I don't want to get into details of right now, right? But important things for us here are reduce input groups that we have already discussed, right? Group is basically how many unique keys were encountered, right? And there were 3 groups. So a group is basically, if you look at this, so these are the groups, right? 3 groups: one for sales, one for engineering, one for IT, right? And then reduce shuffle bytes. This is like because map output materialized bytes are 94, so though all those bytes were shuffled, right? And then reduce input records. So when you say reduce input records, that is 8 because it has to be equal to the map output records. But out of these 8 records, the framework created 3 groups, right? And then finally reduce output records. Make sense, guys? Anybody has any questions around this? Anything else you want me to try out, or do you think it's pretty clear with these 2 examples? Okay, I talked about showing you code where we could override some of the default behaviors of the system, right? So let's not get into details of everything, but let me just show you how you can override things. So here I have a lot of things. Let me just first show you the main class here. So this is another program that I had written. Okay, Here if you see, apart from mapper and reducer class, I am setting some other parameters, right? If you look at these parameters, I am setting the sort comparator class, I am setting grouping comparator class, and I am setting partitioner, my own partitioner. So these are the places, these are the classes that I have implemented to override the default behavior of the system. So for example, my partitioner is a partitioner that I have written which will override the default system partitioner. Let me just show you the implementation of my partitioner. So this is like my partitioner which has a get partition function, right? It takes, as I said, it will take key, value and number of reducers as input, right? And what I'm doing here is I am again using hash only, but I'm using hash on a part of the key. Right now my key is not a text here, it's my own implementation, right? And that my own implementation contains two things, category and count. Okay, and I don't want to partition based on the complete key. I want to partition based on only category here. So that is why I had to write my own partitioner, because the default partitioner would have considered the complete key to calculate the hash, right? The default partitioner would have just calculated hash on the complete key, and that is what I don't want. What I want is every record with the same category should go to the same reducer, even if the count is different, right? That is why I wrote my own partitioner. And in my partitioner, what I have done is I am calculating hash only on the key dot category, and then taking mode with the number of partitions, so that all the records with the same category should reach the same reducer, right? Similarly, I have uh, overridden the grouping comparator, because in grouping comparator also I want to group just based on the I want to group just based on the category and not based on the count. Does that make sense, guys? Okay, Eva is saying, are there ready available codes that we can copy and change for the non-Java experts? So Eva, basically for non-Java people, Hadoop has Pig and Hive. Okay, Pig and Hive, as I mentioned earlier in my first session, Pig and Hive, in fact in last session, Pig and Hive are tools that are for non-Java people, non-programmers. You can write your logic in terms of scripting or SQL queries, and framework will convert those queries into MapReduce jobs itself. You don't need to write any Java code. All right, guys. So we did not look at the slides at all today. Let me just go through the slides. Let me see what exactly I had. Yeah. So combiner we have discussed. The combiner is like a mini reducer. It performs a local reduce, right? So with this we have already discussed. So for example, if mapper one is generating this output, combiner can reduce it to this output, right? Before it actually reaches the reducer node, right? And then we have talked about partitioner also, how output from different mappers will reach different reducers, right? So that concept is clear. So we know partitioner basically decides the reducer ID to which a particular record should go. All right, so these are some of the advanced concepts that are not part of this session, like input splits, input formats, output formats, custom grouping, right? Like the things that I just showed you, right? So in our full course we get into deep concepts of all these things also. So basically in our full course there is a session, full-fledged session on advanced MapReduce concepts. All right, so we have Lee back. So Lee has some questions for you guys. What is the role of combiner in MapReduce? Or in other words, what are the advantages of using a combiner in MapReduce? So Nitin is asking for that. Can I join the full course? Yes, Nitin. So you can join the full course and you will get to know about all the Hive. Let me actually open our website and show you the contents of for the full course. So we have all the information about the courses. So we have Hadoop developer course, which is like a full-fledged course of Hadoop, and then this is the fast track course that we are just going through. And we also have a mock interview uh, concept where you can register for one of the mock interviews, and we'll take two sessions, two 1 hour rounds, and we'll kind of give you detailed report about your weaknesses or your strengths or areas of improvement. So in Hadoop developer course, let me just open this and show you the contents of this course. So we have introduction to big data and HDFS architecture, Hadoop architecture and Yarn, and MapReduce. These are the three sessions that are part of Hadoop fast track course as well. And then after that we have advanced MapReduce, where we'll cover all these advanced concepts of MapReduce. And then fifth session is completely on Pig. And then we have Hive, one session on Hive, and then one session of advanced Hive and HBase. HBase is again a NoSQL database on top of Hadoop. Then we talk about advanced concepts of HBase, and the ninth session is about Spark. So in this session we basically cover some of the differences between Spark and MapReduce and the use cases where Spark fits better. And the last session is on workflow management using Uzi, and we talk about a full-fledged project there. Yep, Eva, you're right. Combiner is a mini reducer for Mapper. It reduces the traffic. Yes, Shaveta, that's right. It reduces the load uh, on reducer and also traffic from Mapper to reducer. That's correct, guys. Okay, Eva is saying please send the link for the full course to us. Thanks. Yeah, Eva, so it's present on our website www.selfreflex.com. So let me just send that link to everyone. Nitin is asking, will we get some discount? So that's a difficult question to answer right now. Yeah, so Kumar is asking about the fee. So Kumar, for Hadoop fast track course, the fee is 5,999, I think, which you all got for free as a promotional offer. For the full-fledged course, the fee is 15,999. But I'm sure for all the subscribers of fast track course, whether it was free for you or whether you paid for it, there will be discount available for the full course as well. I'm not sure how much discount right now, but you'll get an email if there is any discount for you guys. Yep, you are welcome, Eva. So, guys, as I said, right after this session, maybe tomorrow or in a day or two, you will get an email with the details of the project that you have to do. And once you complete the project, you will be awarded an Hadoop developer certificate from us. And we'll also put the details of everyone who has got that certificate from us on our website, so that anybody who wants to verify that certificate, it can be verified easily, right? And for that, I request all of you to send your uh, you know uh, either LinkedIn profile link or your social media profile link to us, right? So that we can put your details on our website. And if you have any query regarding project or any query regarding things that we have discussed in the class, you are free to write to us. And if you have any friends, and if you want to refer your friends to us, then please do that. You'll probably get discounts on that too. Okay, Kumar is saying, is this certificate internationally recognized? Yeah, Kumar. So basically, let me tell you myself. Before actually starting SelfReflex, I was, as I said, I was working in big data projects for many clients. And while working on those projects, I was hiring a lot of big data developers. And when every time when I wanted big data developers, I just got people who were good in analytical skills, but I did not get anybody who had done such course or any project on big data. So it was very difficult for us because we first hired some people and then we trained them ourselves before we could actually use them in the projects, right? So if you actually have worked on any project, if you have attended such training, this certificate is definitely going to help you in getting a better job or better promotion in your current organization. So Shweta, there is no time limit as such, but generally, everyone who gets this project, generally, people finish it within a week or maximum 2 weeks. Otherwise, there is no time limit from our side as such. So, guys, if you liked these sessions, if you liked the way we explained all the concepts, please tell your friends, please refer them. You will get discount also, and your friends will also get discounts if you refer them, and probably we can help each other, right? So that was the whole purpose of this promotional offer. So if we can help each other, that will be perfect. Eva is saying, will just the fast track help finish the project? So Eva, as I said, the project that you guys will get, it will be actually based on this fast track course, all the concepts that we have discussed in this course only. All right. And for all the subscribers of full-fledged course, the project is actually a little bit bigger in scope, which covers all the concepts that we cover in the full-fledged course. So the project that you guys will get, it will be doable with all the concepts that we have covered in these sessions. Okay, Kumar is saying, what is the difference between fast track and full course? So Kumar, as I said, in fast track course we covered three first three sessions of the full course. So there are total 10 sessions in the full course, right? We covered first three sessions, which is introduction to big data, Hadoop architecture and Yarn, and MapReduce. Okay, and in fact, MapReduce is also, I would say, half of all that we cover in the full-fledged course, because in full-fledged course there is one more session on advanced MapReduce. And then in full-fledged course, there are 6 more sessions on other components of Hadoop ecosystem. Like as I said, for non-Java programmers, Pig and Hive are more important than MapReduce. So fifth and sixth sessions are on Pig and Hive. And then we have HBase also, which is a NoSQL database, which again itself is one of the components of Hadoop ecosystem. And then we cover the basics of Spark as well in the full-fledged course. Okay, is it possible to get an intro job with just the fast track? So let me tell you guys, when I started working on Hadoop, for first 3 years, I was just aware of HDFS and MapReduce. I did not know about Pig or Hive or HBase or any other components of Hadoop ecosystem, right? And in fact, that is one of the reasons I came up with this idea of fast track course. I looked at multiple courses offered by different vendors, and none of them is actually offering the crux of Hadoop ecosystem, which is HDFS and MapReduce. And that is the reason I came up with this course, which is fast track course, which is the crux of whole Hadoop ecosystem. If you understand HDFS and MapReduce, value wise, it is actually 60 to 70% value of total Hadoop course. Content wise, it is 30%, but value wise, I would say it is 60%. So definitely, if you know HDFS and MapReduce, it is actually pretty good for you. And at least, as I said, when I was working on big data projects, like if I got anybody who was familiar with HDFS or MapReduce, I definitely would give preference to those people. Any other questions, guys? Okay, by saying so, what can we emphasize on a resume for now before going into details? I need to find the job so I can have more money to spend on training. That's a good one. So, Eva, as I said, you can definitely see once you get the certificate, you can definitely flaunt that certificate. You can definitely, boast about it. You can definitely say that I am a Hadoop, certified developer, right, of HDFS and MapReduce, and you can always put that link of our website where we'll display your profile along with your certification. You can put that link in your resume, and that will definitely help you out in getting edge over the others. Any other questions, guys? All right, I think that's all then. So guys, you'll get email about the project, and you'll also get email requesting for your LinkedIn or any social media profile. So if you can revert to that email soon, that will be great. Okay, Nitin is saying, and if you want, you can take mock interview session with us. Yeah, so Nitin, of course, you can also, go ahead with the mock interview session if you want. So basically, mock interview session is something that is uh, to help you prepare for the interviews. So, for example, we'll ask you some questions, and based on that, we'll generate a report for you, right? A personalized report in which we'll tell you what are the areas where you are weak, and what are the areas where you are strong, and what are the things you need to work on before you go for actual interviews. So that is like I think the charges for that is 999, so which is just around 1,000 rupees, and you can try that out, and you'll get to know better about yourself. In fact, let me just tell you one more thing here. When I started SelfReflex, the name SelfReflex came from idea of mock interviews. So I thought of providing mock interviews to students so that they can kind of look at their own reflection. So that is the place, that is the idea behind which that is the history behind name of SelfReflex. Okay, if I saying, does the mock come with the class, and is it after the project? So Iva, that mock interview is as part of the full-fledged course. So with full-fledged course, that comes as a free advantage, but that's not as part of the fast track course. If you want to register, you can always go to our website, and you can register from this link, right? So we have this uh, kind of online store where you can purchase an mock interview. Yeah, the charges for the mock interview are 699, not even 1,000 rupees, right? So the full-fledged course is 15,999, and the fast track course was 6,000 rupees. But I think most of you got it for free in this particular batch. So if you want to register for any of these, just write to us, and probably as you are subscribers of one of our courses earlier, so you'll definitely get some discounts. Okay, Eva is saying, how much is that in dollars? 699. So Eva, I would say that's around $10. So the price of a dollar is around 65 to 70 rupees, I guess. So that should be around $10. Rajesh is saying, isn't change, you will be referring us your Hadoop intro jobs after we finish the project? So, Rajesh, again, that is something which is part of our full-fledged course, but we will definitely be happy to, refer you to any open positions that we get from our business partners. So we have some, business partners as well who are, hiring big data developers. So we'll definitely refer you guys if they have any openings at this moment. But for full-fledged course subscribers, we make sure that we refer them to a lot of companies where they can appear for interviews. Yep, Eva. So 15999 is around. I think it should be around $200. It's not 159. It should be around $200. I think. All right, that's all then, guys. Hope to see you soon again, and all the best for your careers. And it was really nice interacting with you all. If I think you did not complete the sentence, do you want to write anything? If I saying so with full fledged, I can get and or next week. How long is the full fledged? So if the full fledged course has 10 sessions, and all the sessions will be weekend sessions. So two sessions per weekend, right? One on Saturday and one on Sunday. So it will be of 5 weeks. Thanks, Shweta. Thanks a lot. And guys, please, before you leave, please don't forget to leave your feedback. And in fact, it'll be much better if you can leave your feedback on our Facebook page, because so that others can also see. That'll be great. And thanks a lot for your time and all the best. Thank you all.